In this video, we want to prove the universal coefficient theorem for cohomology. Recall that we were hoping that the cohomology group and the homology groups of a chain complex would be dual to each other. Well, it's going to be true if G is free abelian, but it's not true in general. However, we do have a surjective map from the cohomology group to the dual of the homology group. In this video, we're gonna define this map, show that it's surjective, and find its kernel. Then we're gonna show that this short exact sequence splits. This will allow us to decompose the cohomology group as the direct sum of this kernel with the dual of the homology group. This is the content of the universal coefficient theorem for cohomology. So let us start by zooming in to this map here. Let's define this map. A class in this cohomology group must be represented by some cocycle psi, i.e. a homomorphism from the nth chain to G, which lies in the kernel of the co-boundary map. That means this pullback map here must be 0. Now observe that the fact that this map is 0 implies that this composition must be 0, i.e. psi must vanish on the image of this boundary map. But the image of this boundary map is just a group of n boundaries. After all, that's where the name comes from. Therefore, psi maps all the boundaries to 0. Thus, it must factor through this quotient of the n chains by the n boundaries. In particular, if we restrict psi to the n cycles, then the map factors through the quotient of the n cycles by the n boundaries. And that is just the nth homology group of C. Thus, we can define this homomorphism by sending every psi to this induced map psi bar from the nth homology group to G. Thus, every n cocycle can be viewed as an element of the dual group of the nth homology group. Now, let's show that this map is surjective. That is, let's start with a map phi here and try to find a map inducing it. To do so, we need to use the following short exact sequence. We claim that the sequence splits. Why is that? Well, that's because Bn-1 lies inside this free abelian group, and thus it itself must be free. Therefore, we should be able to define a section from Bn-1 back to Cn. This will give us splitting for this sequence. Now, since this sequence splits, we must have a projection map from Cn to Zn, because Cn is going to be the direct sum of Zn with Bn-1. Thus, if this given map phi here on this quotient has a representative psi naught, then we can pull this psi naught back along P to get this n cochain. One can check that the map psi defined this way is indeed going to be an n cocycle. And thus this map is indeed surjective. Up next, we want to find its kernel. That's going to be the content of the next video.